Hello and welcome back to part 4 of the Heathkit H8 Computer series. This time around I'm going to try to get this computer to do a little bit more than we've seen before. You might remember last time that I was able to get it operating to save and load programs from cassette tape. Now it's time to make this computer just a little bit more functional. There's only so much we can do with those front panel LED displays and keypad. So we're going to need to get some kind of a terminal set up to work with this. Now, no, I'm not ready to connect up the Heathkit H9 terminal that I have. I still have quite a bit of work to do on it before it's going to be ready. But we can use a terminal emulator. Now to prepare for that, I'm going to need to put together a cable so that I can connect my laptop computer to the Heathkit H8. And basically I've just cut in half a straight through 9-pin serial cable, and then I'm going to add some Mulex pins to this, just the transmit receive lines and a ground, so that I can go ahead and just push those pins into the connector on the back of the Heathkit. The other end of the cable will attach to a 9-pin to USB cable that I'll be plugging into my laptop. I have two goals for today. One goal is to get Benton Harbor Basic working on this computer, and I'm actually probably going to try to get extended Benton Harbor Basic version 2 up and running. Now goal number 2 is to find a way to get a copy of Benton Harbor Basic onto cassette tape so that I can load it to the H8. This time I'll be using a different cassette recorder. This one has both a tape counter and the ability to rewind tapes even when the remote cable is plugged in. I've had a lot of great support on this project from the Society of 8-Bit Heathkit Computerists, both on the Google Groups and the Discord server, and the website for the group has some excellent resources in terms of manuals, images of software, and all kinds of different things to make this job a lot easier. And I'll be using some of those resources today. One of the things I'll be using is a manual for the H8-5 serial I/O and cassette interface card. The manual has a couple of different tests that I'll be using. The first one is a test where we send characters to the terminal and we can verify that's operating. And for the terminal today, I'm going to be using the H19 emulator by Les Bird. This first test is really a pretty simple one. We just key in a few commands to the UART, and then we'll be able to send a character from the H8 to the terminal. Now what will happen is once we key this sequence in, every time I tap the out key on the front panel, we'll send an A character to the terminal. Now we should see that on the screen each time I press it. And there we have it. So it is working. We are able to send characters from the H8 to the terminal. Next we're going to have to test sending characters from the terminal back to the Heathkit H8. Now to do this, it'll be a very similar process. In fact, the first part is exactly the same. We'll be sending a couple of commands to the UART, but what's different is we'll actually be typing keys on the terminal, and then we will be hitting the in key on the front panel in order to display what character we typed. So ideally what will happen is once we type in the sequence, we should be able to type an A key on the terminal, and then when we read that input, we should see a 101 displayed to the far left side of the display, and we do. So in theory, we are able to read keystrokes from the terminal. Now just to play around with this a little bit, we can send things other than just the A character. So what I'm going to do is send some keystrokes from the terminal back to the Heathkit. And every time I do this, I'm going to have to hit the in key, and then if I hit the out key again, it will actually echo that back to the terminal. So I can play around with this just a little bit and type out a sequence of characters. So I'm going to try hello world. So I would hit the H, then hit in on the front panel, then out on the front panel to echo it back to the terminal. Same thing with E, then hit input, and then out to echo it back to the terminal, rinse and repeat. So a series of in to collect the character, out to echo the character back to the terminal screen again, and we end up with the world's slowest, most painfully typed hello world ever. Now that we're talking to the terminal, it's time to figure out how to get our copy of Benton Harbor Basic. Now, one of the things that I have is a WAV file of extended Benton Harbor Basic 2, and I'm going to try to get that from my iPad onto a cassette tape. Now, one of the difficulties is the output from the iPad is a 3.5 millimeter jack that is split up between left, right channel, ground, and microphone. So I created a cable that allows me to just send a mono output from the iPad into a cassette deck, and then I played the WAV file, recorded my copy of Benton Harbor Basic onto cassette tape, and once I got everything connected up, got my tape recorded, I was able to test and verify that I was getting kind of data tones on my cassette tape recording. Now, some of you are probably already thinking, that's probably not going to work because we've turned the original files into a WAV, from a WAV back into an analog audio file, and if you're really thinking that this isn't going to work, well, I don't have any surprises for you. It didn't work. And I played around with playing the WAV file directly from the iPad into the H8. That also did not work. So, time for a new strategy. And I think that new strategy will involve doing a direct injection of the digital signals into the Heathkit H8. Now, how are we going to do that, you ask? Well, first we're going to need a copy of the extended Benton Harbor Basic files, and we're not going to use .wav files this time, but instead we're using a file type called H8T, where the T stands for tape files. And these are conversions of those original audio tapes back into digital format. Thankfully, there are a copy of such files on the Society of 8-Bit Heathkit Computerist wiki page. So I went there and downloaded the appropriate files, and now it's a matter of how are we going to get those digital files into the H8? Well, we're going to do that thanks to a handy little board that plugs into one of the UART sockets, actually the top one that runs the audio cassette interface, and it uses a little SparkFun adapter, and we'll be able to connect that by USB-C back to my laptop. So the first thing we have to do is we have to pull the top UART off of the H8.5 board and plug it into the little SparkFun adapter board, and then plug that back into the socket. Now this is letting us bypass all of that cassette circuitry and inject that digital signal from the H8T file right into the UART. Well, now with the H8-5 reinstalled into the computer, it's time to connect up our cable to the laptop and figure out what software we're going to need to finish this process up. After doing a little research, I picked a software called RealTerm, and it's really easy to use. You just basically pick your baud rate and your serial port just from the configuration screen, and don't forget to click change. I did that a few times and had some real problems from it. Then the next thing you do is you just select your file that you want to send to the H8, and in this case I'll be looking for my copy of extended Benton Harbor Basic 2, which I have as an H8T file. So we select that, and I discovered for the most part that you can leave the other settings in their default configuration. I really didn't change anything here. Now on the Heathkit H8, you're going to hit the load button just as if you were going to load a piece of cassette software. When you do this, you'll see the CTS indicator on the right-hand side of the RealTerm window go green, and that indicates you've got your connection. Then you simply select the file to send, and when you do, You'll see some indications of that on the right-hand side of the RealTerm window, as well as if you look down inside of the H8 at the SparkFun board, you'll see a yellow light indicating that there is activity. So this takes a little bit to load up, so there's a little bit of hurry up and wait with this process, and it's a lot quicker than cassette, but by no means, by modern standards, is it a very fast process to load. So one of the other indicators you'll see that something's happening is if you look at the front panel of the H8, you'll be able to see the software actually loading very rapidly, a byte at a time, as indicated on the front panel. And once we get everything up and running, we'll go back to our H19 emulator, and we'll see if we succeeded. So we go ahead and hit go, and yes indeed, we have extended Benton Harbor Basic. And this is kind of exciting to see this computer actually do something besides flash its front panel lights. And if we use the free command, we can actually see the status of memory usage, and down at the bottom you notice that we have quite a bit of free memory. This is set up as basically a 56K system. There's a 64K memory board in there with 56K available for the system to use. So now the next thing I needed to figure out was, how am I going to get this software back to tape? Because I plugged the SparkFun in where the UART goes for the tape, so now I've got the Benton Harbor Basic in memory, but I can't get it written back out or dumped back out to cassette. So I had this idea that maybe I could put a switch in, and I have this 4-pole double throw switch, and I have 4 lines that I need to switch back and forth. So I thought, well, maybe I can put this in. So I can leave the ground in place. I don't need to really do anything with that, but the send and receive, and then there's another wire in there that connects a couple of pins together on the UART. I could interrupt those with the switch and mount the switch up and just flip back and forth, leaving the SparkFun in place, and switch back and forth from cassette to the ability to do the digital load to the system. So I decided to post a message to the Society of 8-Bit Heathkit Computerist Discord server about my idea, and I immediately got a reply that kind of said, well, you know, there's an easier way. You can actually take out the bottom UART from the H8.5 board, plug the SparkFun in there, and then there's a switch on the board that basically lets you flip the UARTs. So the idea is you just leave it in place and then flip a switch that's already present to go back and forth between loading the digital files and being able to write files out to tape. So I went ahead and flipped things around, remounted the SparkFun in the lower slot on the H8.5 board, and once I had that done, it was just a matter of connecting up the cable, reinstalling the card, and flipping the switch up above to flip the UARTs. So if this works correctly, this is going to be a vastly simpler way to get HT8 files back to cassette tape, and without having to do a lot of modifications or to switch things around. So what I did was to, just as before, I loaded the Benton Harbor Basic digitally, and you can see in the video that we do have the yellow light on the SparkFun, so we can see that we are downloading the software. And after a few minutes go by, we have it loaded on the H8. So I try flipping the switch, and then once I do that, I'm going to go ahead and do a dump to tape. Well, some of you might be wondering why I really want to do all of this work with tape to begin with. Why don't I just go ahead and leave the SparkFun installed and just regularly load files digitally? It certainly seems much more efficient, and it's much faster. But my goal here with this entire system is to try to get this as much like it would have operated in about 1978 as possible. So the goal is to have this be a vanilla system from end to end with the disk drives, tape drive, the H8, and the terminal, so that we have no modern technology involved. I really want to be kind of a purist on this, because what I'd like to do is to be able to take this machine to different venues, maybe like a VCF West event, and set the machine up and let people see how this would have operated. So kind of like a traveling museum piece to some extent. Now, I have nothing against modernizing these old systems so that they're a little more convenient to use, or trying to maximize how well they operate. But I think it's important that we give a realistic vision to folks about how these old computers work if we're in kind of an educational situation about the machines. So it doesn't make a lot of sense to take something that has, 1,000 or 10,000 times the computing horsepower and connecting up to the machine just to load programs or act as a video display terminal. That kind of defeats the purpose. And I know that I heard down at VCF West around some of the exhibit floor, I would hear people once in a while, especially younger folks, kind of saying, well, that's interesting. Why don't you just emulate it? Or why don't you just run that on that device instead of the powerful device, instead of having it attached to this old computer? So I think one of the ways we get around that is to go ahead and actually display these computers in as much of their original form as is practical. Then there's another side of this for me, and that's kind of the nostalgia of working with the system in its original form like this. When I think back to 1978, as I've mentioned before, I was a high school student taking a high school programming class on a digital PDP-8 system. And of course, I was combing through magazines at that time, looking at ads for computers from Ohio Scientific. I was looking at Kim 1 boards. I was looking at ELF computer kits. I built one of the projects like that from Popular Electronics. I built part 1 and 2 of the ELF computer. I also had a Netronics version of the ELF 2. And of course, in those days, in my wildest dreams, I could never have had access to or been able to afford something like a Heathkit H8 full system with all of its components. And so I can just transport myself a little bit back to those times and really see what it would have been like had I been able to have a computer like this of my own. So I can never overemphasize the nostalgia effect that I'm having with this, and how much I'm enjoying this computer and enjoying getting to know other people that share a passion for it. Well, it looks like we are loaded up. I'm going to go ahead and indeed launch Extended Benton Harbor Basic from tape. So the tape dump we did worked, and we are in the system in BASIC. So it's very satisfying to see this. Now, it's only appropriate that in some really clunky typing that we go ahead and do a basic Hello World program. And thank goodness I'm not getting graded on my typing, because there's a lot of problems. And one of the things that's weird about the Heathkit is its autocomplete gets me really thrown off. I'll start to type out an entire word, and before I know it, I've got an instruction and then a bunch of gibberish following it, which is stuff that indeed I did type, but wasn't expecting the autocomplete. All right, so we'll list our program, type run, and we've done our first hand-entered program from a tape-loaded version of Extended Benton Harbor Basic 2. Well, the next thing that I need to work on is to get that H9 terminal going. I know a lot of you are probably waiting for me to get started on that, but one of the things that I am waiting on are some parts. I've put orders out for some capacitor replacements. I am going to replace all of the 25 volt tantalum capacitors. There's some 2.2 microfarad tantalum caps that seem to have been very failure prone when I was working on the H8. And rather than to take any chances, I'm just going to go ahead and order kind of a bulk supply of those replace them all with a 35 volt upgraded cap, and hopefully everything will run smoothly there. So that's what's coming up. Thank you again for watching. I hope you're enjoying traveling on this journey with me. I know it's been a lot of fun for me, and I hope you'll continue to watch and consider giving this a like and subscribe. And thank you again for all of the great comments. They're very much appreciated. Well, that's it until next time.